Okay, so this lesson is meant to be an attachment to a resource for Chapter 2, Lesson 2 of our Envision resource, using properties of equality to solve for a variable. So in this case, we're trying to solve for the identity of the variable x, and we know that x has a 4 being added to it. So 4 plus x is equal to a quantity of 7. So I've represented that here with this equation, 4 plus x equals 7. And we're going to do both. We're going to physically show how that happens in reality, how you can make one side of a balance equal the other side of a balance by using the subtraction property of equality. And I'll quickly show you also in written form and through the algorithm how you would go about revealing the identity of x. So back to the balance here. All equations are really balances to begin with. So if you think of the word equation, equal, one side of an equation is already equal to the other. The problem is just that we don't necessarily know the identity of one of the numbers or quantities on the side. In this case, the name of this number is variable x. So in your head, you've already guessed the answer to this. So you know through your math facts that 4 plus 3 is 7. So you already know in your head that the identity of x in this case is 3. And in fact, it is. But the important thing here is that you are able to employ the subtraction property of equality. So what does that mean exactly? Well, it means sort of what it says. It means in order for you to make this equation equal and subtract to reveal the identity of x, you've got to remove or subtract quantities from each side of the equation. And the only quantity we have to subtract from the left side of this equation is the green cubes here, and there are 4 of them. So we remove 4, subtract 4 from one side of the equation, you can see it's unbalanced. In order for the equation to remain balanced, if you subtract 4 from one side, what have you got to do to the other? You have to subtract 4. So we take away 4 from both sides, and the equation balances. In a perfect world, it balances. The scale's a little bit out of calibration. So now I can see, because I've subtracted 4 from each side of the equation, x in fact does equal 3. And if we pull the curtain here, we can tell, you can see that in fact there are 3 red cubes and 3 blue cubes. So 3 is equal to 3. Standard algorithm is not a lot different, except we're dealing with symbols instead of quantities. So 4 plus x, 4 plus x minus 4 is equal to 7 minus 4. What I do to one side, I do to the other. These cancel. X equals whatever 7 minus 4 is. In this case,